Okay, guys, welcome back to today's episode of Thinking with Me, right? And um, my name is Obinna Victor, right? And I build majorly backend and blockchain infrastructure system, right? Um, Around reliability products, right? Around products where mistakes are very, very expensive, right? That's where I flex, if I'm to use the word. I want us to think with me today, right? And so the goal of actually starting maybe teaching like this, right? The end goal is for us to be able to have something at the back of our mind while building anything we are building, right? AI can build faster codes than we can possibly write, right? AI can do a whole lot of design system, like a whole lot of arrangement and a whole lot of stuff that outside of the box it will take us longer time to accomplish, right? But one of the things AI can not help you unless you prompt it well, or one of the things that will show that you're a good engineer is how you reason, right? Your thinking model, how you think about how you approach problem, or how you try to solve problems, right? Um, and so that's why I'm trying to see if I can push this to more like thinking with me, right? Thinking with me when it comes to designing good systems, right? Um, so Now, if this is your first time actually, my name is Obinna Victor, right? Like I said before, and yeah, I majorly build backend and blockchain products, right? Infrastructural products and tools generally, right? And in the last video, I talked about why one RPC provider is not a blockchain reliability, right? And also, just a side note, actually, I would recommend us to read this book um, data intensive application. It's a good book actually. A lot of people have recommended it, and yeah, it's worth reading actually, right? Um, the goal of reading it is just that one of the things you should have at the back of your mind while reading it is that you'll be able to see more options, right? The reason behind why maybe using this application is good, or the reason behind why you should use a specific application or a specific tool to build a specific product, right? That's one of the things you should have at the back of your mind that this book is going to teach you, right? So that's a side note actually. This is not the point of this video, right? So looking at my screen here, you see a flow, right? So I want to invite you, right, to think with me, to just let's think together, right? Like I said before in my previous video, I talked about RPC provider and why one RPC provider is not a blockchain liability, right? And today, I want to talk about another production problem, right? Which also you saw the title while clicking this video, right? Is just a very basic topic, and it's talking about why API success message can actually be a lie, right? And it is not that the API intentionally wants to lie, right, or is intentionally lying. That's not the case. What I mean actually is that the response you get from an API does not really or always represent the full truth of what happened inside of a system, right? It doesn't capture it. And so this matters a lot, in payment systems, blockchain systems, stable coins, wallet infrastructures, and any backends that performs critical external actions, right? This is very, very vital. And so, if you're a backend engineer or if you're an engineer, I want to also invite you to think with me, right? And let's think together, right? maybe you can maybe still learn one or two things from this video, right? You can still learn one or two things from this video. And so I promise you, I'm not here to teach you how to code, right? It's not, that's not it. My goal is just to for us to, you know, think, like I said before, to have a very good mental model, maybe when it comes to building reliable products, right? Across sectors, right? When you have to be, when you want to build reliable and scalable product across sectors, the thinking process, how to arrange or what you should have in mind while building what you're building. So it doesn't matter whether you're not a Rust or Go developer, no matter the language, right? This is actually how you should think. So it's applicable to whether you're writing PHP, TypeScript, whatever language you're writing, right? And so this because in a serious systems, right? The problem is not just the API return success, right? The real question is more like what actually happened, right? What actually happened through the process of this request we sent, right? Was the request accepted? Was the intent recorded, right? Was the external provider called? Did the external provider actually process the intent, right? Did the response return? Did the worker crash, or what happened, right? Like these are the questions we should answer, aside of aside of actually asking a question of did the API actually return success message or not. You know, that's the happy part, right? That's the happy part. And so the critical questions, we should actually engage to know is actually what happened, right? What happened? What happened with the intent, what happened with the external provider, what happened with the processors, did the provider process the information, the workers, what happens, did the webhook arrive early or late, did the reconciliation confirm the final state, right? I know that maybe a lot of us doesn't know what reconciliation means, or what maybe it's been talked about, and we actually maybe break it down a bit in this video, right? And so like I said before, this now this tool I'm using is actually Excel Draw, right? I'm using it to help me actually explain what I'm trying to pass across, the message I'm trying to pass across, so I will be able to think well. Right. By my left hand side, there's some stuff here, right? The card here, and actually I've looked for a way to make this card like to remove this card from here so that it will not be a distraction. I've not gotten away. But if you have a better tool, actually, you can actually recommend. But for now, this is what I'm using. Right. Um. So back to our conversation. Right. Like I said before, this is a naive approach. Right. And I I am like what I want to, the goal now for me is just to, I want to position as a naive developer, and also um a system design guy, that think in systems, that think in architectural design, right? And so thinking like a naive person can be a little bit hard, but I will try as much as possible to do it, because I want to pass across a very good message here, right? And so this is what is happening here, right? That the client sends a message to the API, to the backend API. Right? The backend process the request. We all know what an API means, actually, right? We all know what an API means. An application programming interface, right? So so excuse me. So the backend, right? The backend processes this request that the client sent, right? Um, and the back end returns. Now the processing of the request the client sent also involve calling an external provider, right? And the back end returns a success or failure message, which is this one. So um I'll be using two providers to actually illustrate this, to illustrate my point here, right? Previously I talked about RPC layer. All right, in my previous video. If you not watch that video, just try and watch it, because we try to explain why um building a product with one RPC layer is a bad system design. When you talk about reliability, right? And so let's go back to this video. Actually, I keep drifting away. So the mental model here is that um the request came in and the response went out. And so if the response was success, everything worked. If the response was failure, everything failed. Right? That's the mental model here. That's what this mental model is, right? And this is a very huge problem. And so, and what's the problem here? That success response does not actually means the final truth, right? Because if you look at the mental model we looked at here, it's either you return success, which means that everything worked, or you return failure, which means that everything failed, right? And so for a very basic simple app, this can actually work, right? But this is dangerous when you talk about financial systems, when you talk about blockchain systems, when you talk about infrastructural systems, right? This kind of design is very, very bad. It's very, very critical, right? It's not a design that should ever cross the mind of anybody that calls themselves a blockchain engineer or financial system engineer, or an engineer that actually care about reliability, correctness, right? um because now the problem about this thing, actually this flow, is that this system often depends on external providers, right? And so these external providers must be let's say bank system, let's say paystack, stripe, right? Blockchain RPC providers, wallet infrastructure, stablecoin rails, webhook receivers, third party APIs, right? And the moment your backend depends on an external system, right? Pay close attention. The moment your system depends on external system, the response is no longer the whole truth, right? That's fact. Like that's the fact. Like it's what it is. The response is no longer the whole truth, right? Because an external body is now in the picture. So let's just let me see if I can buttress this a bit, right? So let's say that a user wants to send money, right? So this client wants to send money. Let's say post um three for transaction, right? Wants to send money, and your backend calls a payment provider, which maybe might be Stripe or Paystack or Flutterwave or any bank API, right? But before your bank could have actually received this response from, because now when your bank calls an API, what this back end is telling this provider, it might be let's say this is your back end, right? It's calling a provider, let's say Stripe, um let's say Stripe, uh, pardon my handwriting. So let's use Stripe to just for our example now, right? And this can be any external provider. Right? So your backend calls Stripe to actually process this transaction, right? Pay close attention, flow with me, think with me, right? But before this backend could have actually received the response from Stripe, right? The network timed out, your backend network timed out, right? Remember, your backend was waiting for Stripe to finish and give him a very good response, right? Or a response actually, if it went through or if it didn't went through, right? And now, because you are using this flow, right? Because you're using this flow, your back end timed out, right? Now, what should your back end do? Because now your back end doesn't have any, there's no communication between your back end and the provider itself, right? There's no communication, like no communication, no activity. When you talk about WebSocket I keep deviating, but let me just say this actually. WebSocket is more like is an open communication, right? Let me give an example of what a WebSocket looks like. A normal request and receive from a server, a backend and a client is just a one waiting. You send your server response, right? But WebSocket is more like when you're on a phone call, right, with someone, right, and you can actually talk to the person, and the person can give you feedback without any, like, the channel is open for communication, right? That's how WebSocket works. And a normal call and response is more like you're sending a text message to somebody, you're waiting for the person to reply, right? And now I'm saying that there is no longer way to communicate with this provider, right? And from your back end point of view, this request failed, right? Because why? This was the design system. Remember, the mental model here we talked about is that from this guy here, the mental model we talked about is that when your provider backend returns, or the provider returns success, that means everything was successful. If it returns failure, that means everything failed. That's the design of this, right? And now, because there is no communication between the Stripe and your backend, it will return failure. That means everything failed, right? And so your backend marks it as failed. It may be lying, right? It may be lying, right? If you now try to send this transaction again, or you retry, your backend try to retry blindly, it may send the money twice, right? And so there are two problems here now. The problem here is that there might be duplicates of transaction if you try to retry, and you don't know whether the back end is saying the truth or not. And so your system might be in a state of chaos where we don't really know what to do, and you don't know the action you will take, and it's very very expensive. It might be it's a huge mistake. Imagine when the first transaction you sent was let's say $50,000, right? And you're waiting for Stripe to process this transaction, and maybe for some reason the communication ended, right? And you, because you designed this system as the way you design it, sources of failure, right? Your backend return failed, that everything failed, and your backend tries to retry another $50,000, not knowing whether this process inside of this Stripe have actually went through or not. I hope you're getting the picture now, right? You're getting how dangerous this thing can be, right? Not knowing whether this thing have actually succeeded or failed. And now, because you don't know the state, you retry, and already you don't know whether it failed or let's imagine this from the start point, the first transaction went through. Let's just imagine it, right? You, from your backend standpoint, the transaction failed because your API or your waiter or your worker that was waiting timed out. You now retried, and this Stripe we still process same transaction, same 50. That means you're spending in less than few seconds. You're already spending $100,000 under one transaction, same request, which is very 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 expensive. It's very very expensive, right? um so if your backend tells the, maybe also tells the user that this transaction, the transaction they want to do failed, but the provider now later confirms that it was success, your system has created confusion. Do you get? You're getting the picture now, right? And now what this thing is telling us, that timeout on its own doesn't mean that the system failed, right? There is a difference between your something timed out and terminal failure, right? Failure of whatever it is from your system point, right? And timing out, they are not the same thing, right? I I I want this to sink a bit, right? I want it to sink a bit, let me just assume that I'm too fast. I want it to sink a bit. I hope you've captured the whole picture now. You've captured why building a system like this is very, very bad, right? And now, because you only have two states, right, which is failure and success state, right, your system will keep breaking. Your system will keep losing trust because there is no proper way of handling issues, right? Because at the end of the day, reliability is just it just means that in the presence of failure, things are working as it should, right? And so your backend wasn't reaching stripe, that's a failure. That's a fault, is a fault on its own, right? But reliability say that in the presence of this fault, the system should actually work as it should, right? Right, that's it. Now, and this is very interesting, and we get to where we actually understand how to handle this, right? There is a very professional, better way to handle this, right? And so I want to also talk about another state, right? We all only focus on two states, failure and success, and that's where system breaks, right? That's where systems break. That's where um um systems actually start breaking, right? And so let's actually look at this flow. Let's look at this flow here, right? So your payment flow, you know, your backend calls the provider, right? The provider process actions and network timed out before you get a response from the provider, right? Your backend seizes failure as timeout or seizes timeout as failure, right? Why the actual outcome is unknown, right? And so this is the state I really want to talk about. This is the state I want to talk about. Right? This is the state I want to talk about, the unknown state, right? Because now your backend doesn't know whether this request we sent was successful or not, right? Your backend is not aware, right? It's not aware whether this what we actually sent was successful or not, right? Now I want to still use another example from the blockchain view, right, to try to buttress this in a bit. I say let's say you sent a transaction through an RPC provider, right, and the RPC returns a success response with a signature, right? But that that excuse me. But does that means that the transaction is finalized? Not always, right? It may only mean that the transaction was accepted for broadcast, right? The transaction can still later fail on the blockchain. But now the provider have already returned that okay, this went successfully with the signature, right? But it doesn't really mean that this signature or the success message means that the transaction was successful. Because at the end of the day, this transaction might later fail on the blockchain aspect, right? Right? It can expire, right? It can be dropped. Anything can happen because the blockchain on its own is very noisy, right? It can be confirmed by one provider, right? This transaction might be confirmed by one provider, but not visible yet through another provider, right? Or the RPC request may time out, or even though the transaction actually reached the network, right? So the transaction reached the network, but the RPC layer timed out while waiting for the response from the network, from the block, right? And so again, the response is not the full truth, right? The real truth comes from tracking the transaction life cycle, right? Um, from being submitted to being broadcasted to being confirmed to being finalized, to know whether that finalization, whether it failed, whether it expired, whether it's an unknown state, whether it can be reconciled, right? This is actually the real system model, right? This is how to design a very good system. And now I know when we talk about this unknown state, we are saying that you're giving your system you're giving your backend, you know, right? When you actually introduce an unknown state inside of your failure and success state, right, you're giving your backend more room, right, to accommodate, to handle more failures, right? Because now because we say that timer doesn't mean that your system failed, right, or the transaction failed, that means that there are some there there should be a room, there should be how, right, there should be a room where you can actually design a system, or we can actually package these systems that we don't really know the state, or systems that actually didn't really fail, right? It was just something that we can actually rebuild, or things we can actually restore, right? Because on no state now, when you, let's say, let me give this example actually to buttress this. So let's draw something here. I don't know whether I captured it here. Okay, I didn't. So let's actually draw something here. So this is an unknown state. I'll just use you to actually uh denote this unknown state, right? So these are unknown states, and there are failures that can happen in unknown states. You can call it out of order bound, out of order bound, out of order. I will just use OU. Can have timeout as the um we can have what is it called? Retry. I've forgotten the name of this actually. Forgotten the name of this. A state where you're trying to bombard your workers with a lot of retries, right? And I will use Jetta to actually um, distribute or reallocate timing for these retries, right? I've forgotten the name. Um, so if you know the name, actually, just mention it in the comment section, right? If you know the name. So now these are the few retries I want to talk about now, right? The few failures that can happen in your system. There are a lot of failures actually. But these are the few common ones, right? Now, because you actually gave room for unknown states, right? Um, these failures, when they happen, when timeout happen, right? Because your backend doesn't really know what happened, and there is room for this unknown state, this request will actually be pushed to this unknown state, right? The request will be pushed to unknown state, and instead of the backend returning failure, right? Instead of backend returning failure that this thing failed, right? It will just come here and pack them, right? I want to paint the picture for you. And so what packing it means is that it now gives room for reconciliation to take place, right? When it has to do with timeout, right? When it has to do with timeout, when it has to do with timeout, but when it has to do with also outbound order, right? The conciliation also can take place, but retries is not what reconciliation can handle. It's not what is it called? It's not the work of reconciliation, right? Like I said before, jitter is one of the processes of handling um I think it's called a retry crash. I've forgotten the name, right? But yeah, that's just what it is. Now, let's focus on these two that I know their name already. Right, let's focus on these two. I know their name already. Right, now, when these two actually fails or happens, right, they are being packaged to this place, right? And now, because they are available here, you are now giving room for proper reliability check, right, with reconciliation, right? And so, what is reconciliation? Reconciliation is very basically you trying to know what really happened in this thing. Now the backend doesn't know what happened. For reconciliation, we now have to go to the provider and know what's the real state of this intent exactly. What's the real state of this request, right? And now return the final truth to the backend. Do you get? Have you seen how we are able to solve this problem now? This problem we are talking about. So because there is no communication between the back end, how will you now know that Stripe have succeeded or failed? Is through reconciliation. Is through our reconciliation. And so reconciliation will go to Stripe and pull to check whether this the exact intent have actually happened or not. And now question will still be, how will you know the exact intent? intent has some IDs, have intent name, have a type, and have when this was created, because the complete flow. um Now, when you talk about this file, I just buttress our main topic. The complete flow of this API system, right, is that when an intent comes in, pay close attention. You can see write this down, right? When an intent comes in, right, is being recorded. This intent is being stored in the database, right? That's the difference between this guy and the race system, right? Um, the intent is being stored in a database, is being normalized and pushed durably to the database. And why it's being stored there is not that it has been successful. You stored it there so that the system can know, okay, this is what we have to, this is what we need to work on, right? These are the things we need to work on. When it's being pushed to the database, pay close attention. They are being queued in, what we call queuing in. And so what queuing in means is that they are being actually arranged in order of how they came into the database, right? For workers to pick it up, right? So workers will pick maybe a, let's say we have a one, we have two, we have three. We have three queues here. So this is the first one, this is the second one, this is the third queue, right? Now we have, let's say you have three workers, but workers are just people that actually take up this intent and make sure they are being executed. Right, that's what the work of workers. So let me give you a very vivid example of workers. Example of background workers. There are sometimes you when you send an email, actually generally, when you send an email, right, the email, you might receive a success message that this email have been delivered, right? But actually, what will happen, there are sometimes you might notice that the email, instead of saying sending, it will show queuing, right? That's the email you send, the intent you sent have actually been queued, right? And background workers have not yet, any workers actually, right, or tax manager have not actually picked this request you just sent to push it to where it should go, right? That's why it still show queuing, right? And so that's the work of queuing is just to arrange this request at, it's just for order, right? And so worker one will just pick this one, worker two might pick this one, right? Worker three might pick this one, all right? And so for each worker, right, I'm just trying to talk about how these things work actually. So for each worker of each task, right, you actually give them time limit, right? When you give them time limit, and you make sure that which is important. One of the database I actually recommend while building this kind of systems, where financial system actually is database, PostgreSQL, right, is very very secured and by default has some of these securities, right? Now, when worker one picks a transaction, right, it locks this transaction, and what locks it so that worker two will not want to pick it up, right? Because worker two might want to pick work one because that's the first work in the queue, right? Oh, and notice that this work have already been locked by another worker. This worker will now look for another the next queue work, or the next queue task, right? If it's free to pick it up, if it has been taken, it will move over to the third queue, right? So that why locking is important, right, is that two workers will not be working on one job at the same time. It's very very bad, right? Worker one is working on the job, and not knowing that somebody else have taken the work, and the same work is being worked by another worker, right? And it's not a good place for you to be, right? It's not a good place for you to be. There will be a whole lot of duplicate activity, right? And now when you log this, you time it, because sometimes these workers might crash, right? And what timing does is just that you tell your system, whenever this time is have elapsed and there is no response from this worker yet, just return this work back to the queue, right? Return it back to the queue, right? That's why this is important, because if you don't put this, some a worker might take up a task and just be in an infinity loop, right? So when this when a worker actually picks the task and starts executing, or what we call attempt, right? An attempt record is being created. And so what is the importance of an attempt record? Um so so this is the this is the correct picture here, right? This is the correct design. I've been speaking grammar since. But now, so what's the importance of a attempt record? You know, the attempt record gives us a history to work with. Right? It gives us a, because now when you want to query what really happened on this intent, you want to know the life cycle, how many attempts happened, which attempt went, if an error happened and each attempt, what was the error about. You know, it gives you an overview of what really happened, right? And also it's a good thing for retries, right? It's a good thing for retries because you don't want to retry forever, right? Let's say you attempted attempt, let me use 80 for attempt, just pardon me. Yeah, you attempted the first time, attempted the second time, you attempted the third time, right? And you might structure it in a way that if you attempt three times, just push it to dead letters, right? You can push it to dead letters or replay or whatever, right? This is a very good system design. This now, and now once these workers start executing, they will call a provider, right? It might be a bank or any provider at all, Slack or whatever provider, Discord, Telegram, any external provider at all, right? And try to just call the provider to execute this request for us, right? And the worker will try to be waiting for this execution to happen. Maybe because the provider is down or error is failing or whatever it might happen, this worker here might time out. And because the worker timed out, right, your system on its own should not fail, right? Your system should be able to push this intent to this guy, this unknown state, because you don't really know what happened, right? And now that's where reconciliation, this guy here, comes into play. And what reconciliation does is just like I said before, right? It's just to match what already what happened with what the provider is saying, right? It has to go and check the provider to know, okay, this is, we don't know what's happening here, right? I want to know, get an information from here so that I can be able to feed the back end, right? Instead of trying blindly, right? There is a place of idiopotency, but that's not what we're talking about. We are talking about when you try to call an external provider here, right? The idiopotency comes into play when intent comes in, right? We'll still talk about that. um but yeah, that's just the general. And now what, now for each receipt being created on the database, it must always have an ID, and it must always return an ID. And so what this return ID will do is that if you want to query the database to get an information about this, you know, you can be able to, or an information about the receipt, you can able to do it and know what happened, right? Is a very good way to debug than actually going through the logs. And you know, there is no clarity actually of what happened. Right? There's no clarity of, okay, this is what happened. The provider failed. Actually, the fault was from the provider and not from your system, right? And yeah, that's just how to design this system, a good um back end API system that should not lie. And so I wanted to actually mention something, right? Why a success message can actually be a lie, right? Because I think this have actually helped us to understand why they can lie, right? Because an API success can lie in different ways, right? First, success may only mean that the request was accepted, right? The API might return success because the provider accepted the request we sent out, right? Secondly, success may come from an internal system before the external side effect is full. Do you get? I am saying that the internal system, which is your server, might return success message before the external provider, which might be Stripe or Solana or EVM, can be able to return the full effect of what have already happened, whether it was successful or not, right? For example, right, a payment request was created, but I'm looking for a better example. So a payment request was created, but does not mean that the money has settled where we want it to settle, right? So the payment request was created, obviously, right? And because the payment request was created, from this view now, when the payment method was created, request was created, sorry, it doesn't really mean that this money have actually reached the destination or the beneficiary, right? It just means that this have been created, but we don't know whether this money have reached the provider or the person, or the exact request we are looking for have actually been gotten, or the person we intended for it to receive this request have actually received the request or not. But it has been created and your system can return success message, right? This happens with blockchain transaction, bank transfers, and settlement systems, right? I actually worked with one settlement system, and this was one of their critical um, selling points, where the source of truth is that the beneficiary have actually been credited, and so we use Go language to pull from the beneficiary and to know whether this beneficiary have actually received this transaction or not. And so whatever is happening through the process is not really is a means to an end, right? Even if you reach the settlement gateway, that's not the final source of truth. Our source of truth is that this beneficiary have actually received what they are looking for, and that's a good system design. That's a good way to design a system, right? As well, but in this kind of product now, in this kind of product, this cannot be the case. In this kind of product, this cannot be the case. This can't happen. That's what I'm trying to say. And so, if you want to design a system, this is the flow. This is the kind of flow you should have in mind, right? This is the kind of flow you should have in mind. This is the kind of flow you should have in mind, right? Kind of flow you should have in mind. It will help you know, and also why having this in mind, actually you should know that these are layers, and these layers actually have the roles they play, right? They have, each of them have roles they play, right? There are a lot of reasons why success message in an API doesn't really be cannot actually be can be a lie. Actually, that's what I mean, can be a lie, right? And I think I've actually buttressed this point a bit, right? Because um no, I want to talk about why a bit about failures, right? A failure response does not always mean that the operation failed, like I mentioned. you know it can sometimes mean that the provider timed out. And now this things I'm pointing out is what is very very vital in production systems. You might not pay attention to it when you're building your project, but I mean, when you're building your project, try as much as possible to pay attention to them. But in production systems, they are very very important. You see error handling is very, very important, right? So like I was saying, sometimes providers might time out, the worker might drop, right? The network might be dropped, right? The worker crash after calling the provider, response was lost, webhook did not arrive on time, right? The RPC maybe was stalled, right? The status check was too early. And so failure does not always mean failure, right? It does not always mean failure. Sometimes failure means that we don't know yet what is happening, right? And so that difference changes the whole thing. So we don't know yet what is happening doesn't mean that it failed, right? And so that's why this unknown state is very, very important. And so it's important for you to design your system having this unknown state in mind, right? This is how to build a serious systems, because it must have these three models, right? Success, failures, unknown. Unknown is not a bug. Unknown is a real production state. Unknown means that the system does not yet have enough evidence to safely say that this was a success or a failure, right? And like I said before, it's common in payment system, blockchain system, and webhook deliveries, right? And also common in distributed systems, right? So if your system does not um, model unknown, right, it will force on certain events into a fake success or fake failure, right? And so this guy here is very, very important. You might name it whatever you might want to name it, but it's very, very important, right? And that's why I say this system design is more better, because this system design has unknown to it. Because when you're trying to reconcile what you're reconciling is your unknown states, the ones you're not sure about, right? That's what you're reconciling, things you're not sure about, right? What the system is not yet doesn't have enough truth about, right? And so that this is the correct flow. This is the correct flow, guys. Um, the key idea here, actually, even if you didn't get anything from this brief um thinking with me, right? The key idea here is that API response is not always the truth, right? Durable state is truth, right? The response only tells you what the system knew at that moment, right? But durable execution record tells you the full life cycle, right? It tells you what was requested, what was accepted, what was executed, what failed, what timed out, what was retried, what was reconciled, and what was confirmed, and what receipt was produced. That's the difference between a simple API and a reliable infrastructure. I know that it might be a lot for you to think of, for you to actually work, but believe you me, this is the way to build a good system. And if you don't go this way, you might end up being fired or being sued at the end of the day. If you're not being fired as employer, you might be fired as if you might be sued to court as a founder or an engineer, right? So that is just the flow. That's the flow, actually. That's how this system actually work, right? Also, I just want to talk about, just make a brief disclaimer here, right? About my LinkedIn. Actually, I don't have a LinkedIn account, right? I had one in the past, actually, but they restricted my account for some reasons. And the reasons are just that they say that I was actually doing some malicious activity, which was actually because some people were trying to hack my LinkedIn account. So I've done a lot of verification. I did went through. Yeah. So let me just briefly take us through my repo. Right. Um. So this is a production ready application I'm currently building now. All right. It's called Asms. Right. So it's called Asms, actually. And so this is a platform that actually houses things I've been explaining lately, right? And is an infrastructure, is a financial durable execution system, right? Is a financial durable execution system. And yeah, so I just hosted this on GCP, right? Just hosted this on GCP.